Okay, so we have another revenue type question. So in this question here, revenue again is the number of items times the price per item. So for this question here, the number of items is the people attending the dance. So as it stands right now, we have 300 people that attend a dance and they pay a ticket price, the price per item, of $2 each. So currently my revenue is $600. What I want to find is a way to up that revenue, maximize that revenue. So we do a little survey. We find that every time we increase the price by multiples of 20 cents, we will lose the number of people in multiples of 20 people. So even though we're dropping our attendance by multiples of 20, the people that are staying are still paying more. So it's kind of a balancing act. So my new max revenue question is going to be the 300 people take away multiples of 20 multiplied by the price, which is $2 plus multiples of 20. So let's apply the distributive property, get rid of our brackets. So we're going to do 300 times 2. So we have a max revenue of 600. 300 times our 20 cents. So we do 300 times 20. And we get 0.20 is 60x. Then we do negative 20 multiplied by 2, negative 40x. And negative 20 multiplied by 0.2 is negative 4x squared. So let's write this in descending powers of x. So I have a negative 4x squared. 60 take away 40 is 20x plus 600. Okay, so going down here, let's look. We're just going to focus just on our x terms, and we're going to factor out the leading coefficient, which is the negative 4. So take out the negative 4. Negative 4x squared divided by negative 4 is x squared. 20x divided by negative 4 is negative 5. Leave some room, plus 600. Okay, so over to the grid, we'll complete the square. Oops, I'm missing an x there. There we go. Okay, so I have x squared. I take negative 5x, I split it into 2 equal pieces, like that. And then I factor. So GCF of x, GCF of x. Leading coefficient of negative 2.5 comes out. Leading coefficient of negative 2.5 comes out. Let's just check to see if that is right. So x times x is x squared. Negative 2.5 times x is negative 2.5x. X times negative 2.5, negative 2.5x. And negative 2.5 times negative 2.5 is positive 6.25. So I will add 6.25 and subtract 6.25 inside my brackets. So I do that because 6.25 take away 6.25 is really 0, and I can add 0 to any expression without changing its value. So back down to max revenue, negative 4 times. I'm going to factor my perfect square trinomial, which I know from my grid factors as x minus 2.5 times x minus 2.5, or x minus 2.5 squared. Then I have to deal with that negative 6.25 on the inside. So I'm going to do negative 4 times negative 6.25 and bring that out. So negative 4 times negative 6.25 is positive 25, which I add with the 600 that's already out there. So my max revenue is negative 4 x minus 2.5 squared plus 625. Now let's state our vertex. Opposite on the inside, straight up on the outside. This is what my max or min is. This is when my max or min is. So since I have a negative leading coefficient, I know that my parabola opens down, so I have a maximum. And what that maximum is the maximum revenue. So the maximum revenue is $625. So we increased our revenue by $25. How did we do that? Well, we did that by multiples of 2.5. Now, what I mean by multiples of 2.5 go up here. We lost people in multiples of 20. How many multiples? 2.5. So 30 people subtract 20 times the multiples of 2.5. So 300 takeaway, now I go 20 multiplied by 2.5 is 50. So that means that 250 people will attend. Now, what's the ticket price? We'll go up here. The ticket price was $2 plus multiples of 20 cents. Well, how many multiples? 2.5 multiples. So my tickets were $2 plus, it was multiples of 20 cents. And I had 2.5 multiples. So 0.2 times 2.5 equals 50 cents. So by setting the ticket price at $2.50, having 250 people attending, we would get our maximum revenue of $625. So let's make this a little bit bigger so we can see everything. Make sure I answered my question. How much should be charged? $2.50 should be charged. And that would give me a maximum revenue of $625.